Munich. A design engineer just learns his new product must accommodate a higher input voltage than previously planned. Beijing. A designer facing the deadline for product release has unacceptable current spike during power-up. Boston. A product design team is informed that they must reduce the size of their product by 25%.
These are just some of the complex problems that face design engineers today. When it comes to quickly designing a power supply, design engineers worldwide rely on the Simple Switcher family of regulators from National Semiconductor. And now the Simple Switcher family has been further enhanced, adding more flexibility and increasing performance to solve the real-world problems that we face every day, while still retaining the simplicity that has made these regulators popular with designers everywhere. In the next few minutes, we'll learn how National's newest addition to the Simple Switcher portfolio can be applied to solve complex problems. We'll be working here with National's latest WebBench online design and simulation tools. It's because of recent advancements in these tools that the Simple Switcher family is truly simple to use. Let's get started. Let's say you need to design a power supply with an input of 24 volts and needs to deliver 12 volts at 2 amps. You simply go to power.national.com and plug in your numbers. To provide tolerance, we'll use 21 volts minimum and 27 volts maximum. We'll plug in 12 volts out at 2 amps. And let's use 50 degrees C as an ambient. The tool initially recommends devices based on your requirements. This gives you a chance to select features that you might need, such as soft start or the ability to synchronize to an available clock source. Now here we see that LM25576 is a recommended device. Now this device is one of National's latest additions to the Simple Switcher family. It can handle up to 42 volts in, it operates up to 1 megahertz switching frequency, and it uses a unique emulated current mode architecture which significantly improves the transient load performance. Now after selecting the device, within moments, WebBench provides a recommended design. And here you can find critical parameters such as worst case efficiency, power dissipation of the IC itself, and the footprint for the actual design. Now, WebBench initially provides a balance between the size of the design and the efficiency. And you'll notice this new control knob, we call it an optimization dial, allowing you to quickly modify the design to meet the specific size and efficiency that you require. Now, this new feature automatically recalculates component values and updates the bill of materials and the schematic based on these requirements. Now in this case, let's say you need to reduce the size of the power supply. By simply rotating the dial to the left and clicking on Optimize Circuit, you come up with a new design that in this case is 25% smaller with minimal impact on the efficiency. You can now click on operating values for a more complete list of the actual operating parameters. Now another reason why these Simple Switcher products are so simple to design with is the WebTherm function that allows you to simulate the thermal footprint of your design. With this tool you can not only fix potential thermal problems before you build your PC board, but you can also optimize reliability by running devices at the lowest possible temperature. So there it is. We've created a solution for your product using a new Simple Switcher device, but at the last moment, a change comes in, as always seems to happen. Let's say you're told that you need to support a 48 volt input, and you need to run now up to 60 degrees C ambient. Well, with the flexibility of the product and the WebBench tool, all is not lost. So you enter the new parameters, 43 volts min, 53 volts max, and you set the ambient temperature to 60 degrees C. And now we see the recommended devices change to the pin-compatible LM5576. This new device is another member of the newest Simple Switcher family, which provides an input range all the way up to 75 volts. You click on Start Your Design, and again, we'll optimize for the smallest size. In this case, we see the die temperature is over the maximum of 125 degrees C, and the tool does provide a warning. Now this is based on a worst-case input voltage. I'll increase the size a bit to improve efficiency and then re-optimize the circuit. Now in this case, the maximum die temperature is below the 125 degrees C, and we have an acceptable small footprint. So now you're set. You have an optimized power supply based on National's new simple switcher family. As you can see, they're still simple to design with, yet they now provide flexibility and features that I'm sure you'll find valuable in a future design. So go to power.national.com and put these latest simple switchers to work for you.